So let's end class with another theoretical model. This is a model that will predict the time it takes to drive to a destination. So here is a Google map going from our high school to the amazing store, Evil Mad Scientist, run by some folks I know. You see that it's 8.6 miles. Google estimates it will take 12 minutes. So this is a functional relationship. And you're going to derive and Google's model is probably a combination of math and computer science. It's going to be a computational model, not just a purely mathematical one. But we're going to make a mathematical model. Brainstorm in your groups right now. What are a bunch of factors that might be relevant to predicting the time to a destination? I think you should come up with at least 3. There are probably lots more. Pause the video. So here I've written 3 things down. Factors that might affect my time to destination include things like how much traffic there is, how many stoplights there are and whether or not I hit them, how much I spend, how much time I spend on the freeway versus surface streets. We're missing the most important factor though, and I fully expect you might have missed the most important factor. If we're just going to choose one variable that affects the time to destination, it is probably distance. Like that's the thing that varies, that affects our time to destination. Of course, the speed we drive also. So, take a couple of minutes, write the simplest model that you can, because that's a good way to start modeling. It's always easy to add more complexity, but we want to start with the simplest model. So go ahead and write a mathematical equation that you think will predict the time to destination based on 1 or 2 other things. Like we did before, you should feel free to introduce your own variables and define them. And we'll debrief in a minute, and if you finish your simple model within 10 minutes, then decide how could you incorporate some of these other factors mathematically. It's easy enough to say traffic affects it, but how would you actually get that into an equation in a sensible way? All right, 10 minutes, off you go. All right, so I think the simplest model, let's do this. Let's say t is time to destination. And I think time to destination, the simplest model is going to be just distance times speed. Nope, that's not right. How does this work? So let's think about it. Speed might be in like miles per hour times time, which might be in like hours, and then hours divides hours to give us just miles, which is a distance. But what we're trying to figure out, we're trying to solve for time, right? So let's divide. So time is going to be distance divided by speed. Okay, so this is an example of the simplest model that we could make for expected time to a destination. And I didn't really do a good job of defining my variables here, but the average speed we expect to drive at will be s, and the distance that to our destination will be d. All right, so we got that. Let's start to incorporate some of these other ideas. On the worksheet that I have linked, I have a couple of ideas for how you could think about incorporating the idea of freeway versus surface streets, and another idea about how you could incorporate the idea of traffic. So go ahead, try those out, and we'll do a final debrief right at the end.